Hello students, today we are going to start chapter number 4, Motion in a Plane. Now introduction part, topic number 4.1, one-dimensional motion. Students, we have studied one-dimensional motion in chapter number 3. If the object is moving along the straight line, we call that motion as a one-dimensional motion. Now, when the object is moving on a straight line, only one coordinate changes. That is, the position of the object can be represented by one dimension only. Here you can see a point P is shown in the figure. If somebody asks you that what is the position of point P with respect to origin, then definitely you can say that it is x is equal to 3, as it is towards the positive x direction, that is towards the right hand side. If somebody asks you what is the position of point Q, then definitely as it is on the x-axis, we say that it is x is equal to -1. So either by positive or negative sign, we can get the direction of or the position of the object. Also, if the object is moving towards the right hand side, then we can say that its displacement as well as the velocity is positive. And if the object is moving towards the negative x direction, then we can say that the displacement or the velocity is positive. You can see here only x coordinate is there because it is motion in one dimension. So only one coordinate is required, and by positive or negative sign we can get the direction. Now in this chapter we are going to study about motion in two dimension. Two dimension means we have to consider two coordinates, that is x coordinate as well as y coordinate. In earlier case, only one coordinate was considered, that is either x, or if the motion is along the vertical direction, then only y coordinate may change. But here the motion is along the plane in two dimension, so two coordinates are required. So here x and y coordinates are required to show the position or the displacement or the velocity of an object. Now if I ask you from this figure, what is the position of point P in this xy coordinate system, then definitely you can see that point P, its x coordinate is 2 and its y coordinate is -3. So point P lies at 2, 3. So this shows the exact position of this point. So two coordinates are required for this, because this point P is neither on the x-axis nor on the y-axis. It is somewhere here, and so two coordinates are needed to show the position. Similarly, position of Q, so its x coordinate is -1 and its y coordinate is +1. So students, here there is a printing mistake. X coordinate will be negative and y coordinate will be positive. Always first number represents the x coordinate and second number represents y coordinate. You can see here also. In this way we have to represent the coordinate, and this coordinate shows the position of the object or any point. Similarly, if the object is moving in free space or in air, that is random motion. If the object is having some random motion in a free space or air, then we call that type of motion as a three-dimensional motion. So for that we know that three coordinates changes. Its x coordinate, its y coordinate, and its z coordinate. So such type of motion or the position of the object is represented by x, y, and z coordinate system. Now in this figure you can see there are point P and point Q. So what is the position of point P in this three-dimensional coordinate system? Then definitely you can see here its x coordinate is 2, its y coordinate is 1, and its z coordinate is -2. So 2, 1, -2. So this represents or this shows the position of point P. Similarly, position of point Q. Students, remember from that point we have to draw the perpendicular to the axis. See, from this point if I draw perpendicular line to x-axis, I'll get x coordinate which is -3 here. If I draw perpendicular from point Q towards y-axis, then that will give me its y coordinate. Here it is -1. And from this point if I draw perpendicular to the z-axis, then that point will show me the z coordinate. So -3, -1, 3 is the position of point Q. Students, remember this x-axis, this y-axis, and this z-axis, they are mutually perpendicular to each other. You can see here this line seems not to be perpendicular. It does not look like that it is perpendicular to x-axis and y-axis, but actually it is perpendicular. It is because if you consider this as an x-axis, this as an y-axis, then z-axis will be normal to the plane formed by this x and y, and normally moving into this plane here at point O. So all these three coordinate system are perpendicular to each other. But students, we don't have to worry about this three-dimensional motion. We are only going to study motion in a plane, that is two-dimensional motion, and that two-dimensional motion can be easily predicted or can be easily explained with the help of x and y axis, that is a plane formed by x, y. Now next topic is about scalars and vectors. Topic number 4.2. Now students, what are scalar quantities? Scalar quantities are those physical quantities which have only magnitude but do not have any direction. Means directions are not related to such physical quantities. Examples are given here: temperature, time, mass, density, volume, work, etc. Students, when we measure the temperature, would it have any direction? No, the direction is not there. Only a number is there. Suppose the temperature is 60 degrees Celsius. So this 60 degree, which is a number, it does not have any direction. Definitely, as it is a physical quantity, it has its unit, but it does not have direction. So only number represents those scalar quantities followed by appropriate unit. Suppose time. If I say the time duration of your test is 1 hour, so you can see that 1 hour will be there because it is a unit. So every physical quantity has unit, but this number is a scalar quantity. It does not have any direction here. So time does not have any direction. Can we say that 1 hour in this direction or 1 hour in that direction? No, time does not have any direction. Similarly, mass, density, etc. This type of physical quantities do not have any direction, and so they are scalar quantities. Now, the scalar quantities can be added, subtracted, multiplied or divided as ordinary numbers. Means ordinary algebra are used for their mathematical operations. If I say 2 meter is the length and 1 meter is the breadth of a square, then what is the total? Total is 2 plus 1, that is 3 meter. So this type of simple mathematics are used. But when we say the quantity is a vector quantity, then for vector quantities magnitude is important as well as there should be direction. So those physical quantities which need the direction along with magnitude, then such type of physical quantities are called vector quantities. Here examples are given: velocity, acceleration, force, area, displacement, etc. They are vector quantities. Now students, if I simply say that speed, now what is the speed of the vehicle? And if I say it is 45 km per hour, then it is simply having a number with the unit. No direction is involved with this speed. But when we say velocity, then if I have to represent velocity of the vehicle, then there should be a number. Unit will be always there because it is a physical quantity, but I have to give the information about direction also, because velocity is a vector quantity and so the direction is important. In which direction the object is moving, that is to be specified, and that can be specified by vectors. Students, Vector quantities, they obey specific law of combination. As we have seen that in our scalar quantities, ordinary algebra are used, which we daily use in our day-to-day life, normal mathematics. But here for vectors, for vector addition or vector multiplication or vector division, the normal algebra are not useful. Here specific combination or specific algebras are used. Here given that if we want to add two vectors, then there is a law of triangle or law of parallelogram which are used for the addition or the subtraction of two vector quantities, and this we will study in this chapter. Here only information is given that how we can add two vectors. So there is a method called the method of triangle as well as a method of parallelogram for such mathematical operation. Now representation of vector. How vector is represented? So students, you can see here a figure. Vector is represented like an arrow. It is simply like an arrow. This is called the tail. This end point is called the tail, and or we can say that it is a starting point. And this, where the arrow is there, that is called the head of a vector. So this is a vector where this is called tail and this is called head. Also you can see here I have given the example how the vectors are represented. Here a vector quantity and the symbol, that is how this vector is represented, is given. Velocity is represented as v and a vector sign on it. Displacement, delta r, and there should be a vector sign. So this is displacement. Acceleration, in our earlier chapter, that is chapter number 3, we have simply used a because it was one-dimensional motion. So we have used a negative or positive sign for acceleration to show the direction. But now here a vector is used on the symbol a. Students, in your textbook, wherever you see the bold letters, that shows a vector, but whenever you write that in your notebook, you have to show symbol showing this sign above the quantity. That means in textbook, velocity is represented as simply v by bold letter, but if it is a bold letter, means it has a vector on it. So whenever you write v, bold v in your notebook, don't make it dark, don't make it bold in your notebook, put a vector sign. Now about position and displacement vectors. Students, to describe the position of an object moving in a plane with respect to some reference point, usually xy plane is considered because it is a two-dimensional motion. So two coordinates are used, x and y. A reference point is needed to show the position. means point of observation. Reference point means point of observation. But when we take the xy plane, the reference point is generally taken as the origin of that coordinate system, that is xy coordinate system. So origin is considered as a reference point in xy coordinate system. Now let us see what is position vector and displacement vector. You can see in a figure. Here this figure shows x-axis, y-axis, and the intersection of x and y-axis is point O. This point O is the origin of this coordinate system. That is a reference point. Now suppose if the object is moving in this xy plane and its path is shown by this curved path. This curved line is nothing but is path of the object which is moving in this direction. So now suppose during the motion of this object, if it is here at point P at some time interval, that is t1, the position of the object is at point P, and after some time it is moved to point Q. Let that time is time t2 when it is at point Q. So what is the initial position of the object? So we know that the initial position is point P. And what is the final position? The final position is point Q at time t2. Initial position is P at time t1. But if I want to show this position with respect to reference point, that is origin, then I have to show that position by a vector. You can see this vector. It shows the position of point P, that is initial position of the object. So this arrow which shows the position with respect to origin is nothing but the position vector, and here that position vector is represented by r1, and there is a vector sign on it. Similarly, after some time, that is at time t is equal to t2, the object is at point Q. Again, if I want to show the position of this point Q, then with respect to origin, this arrow shows the position of point Q, and so it is called a position vector, and here that position vector is denoted by r2. So r1 is the initial position vector and r2 is the final position vector. So students, you can see here this OP, vector OP is symbolically represented as vector r1. You can see in figure this O2P is nothing but it is vector OP, but symbolically we have represented it as vector r1. Similarly, vector OQ is symbolically represented as vector r2. So these two are nothing but the position vectors which shows the position of an object at different times t1 and t2. These are the different times of these different positions P and Q. Now if I ask you what is the difference of this position, that is nothing but the displacement. Difference of this position gives the displacement. So from initial position to to final position. You can see this vector from P towards Q. So this is nothing but the displacement vector shown by delta r, that is PQ, vector PQ, which is symbolically represented as vector delta r, is nothing but it is a displacement vector. Now if we want to express this delta r in terms of position vectors, then this displacement vector delta r is nothing but the final position minus initial position, but final position is represented as vector r2 and initial position is represented as vector r1. So difference of these two vectors, that is difference of these two position vectors, gives us the displacement of an object. Similarly, delta t, that is difference in time, final time minus initial time, gives the difference of the time. So students, remember, this displacement is a vector quantity, but time or difference of time, it is a scalar. So there is no vector sign on this time. Students, this you know that the curved path represented in the figure, this curved path along PQ is the path length. It is called path length of the object which is in motion. But when we draw straight line from P to Q, then that is displacement. So here I have written that this curved path PQ is a path length, or we simply say that it is a distance travelled by an object, while vector PQ represents displacement. This vector PQ is nothing but it is a straight line from P to Q, and it is clear that displacement is the minimum distance between the initial and the final positions, because whenever we draw straight line from P to Q, then that will be the minimum distance between P and Q, because if we consider this distance, then it is larger than this straight line. If I say from P to Q this way, then this will be again larger path, but the straight line path is the shortest or the smallest distance, and that smallest distance is nothing but it is displacement. So finally, if I take magnitude of displacement, then that displacement can be either small or equal to, that is less than or equal to the path length. And this we have also studied in chapter number 3, that displacement is less than or equal to the path length. Displacement can be negative, positive or 0, but path length is always positive. Now about equality of vectors. Two vectors are said to be equal if they have same magnitude and same direction. Here you can see in figure that there are two vectors, vectors A and B are given. Here you can see that these two vectors have equal or same length, length of vector A as well as length of vector B, they are same. Hence, if the lengths are same, we can say that they are having same magnitude. Also, you can see that the direction of this vector, vector A, is this. Also, the direction of vector B is also along that direction only. They are parallel to each other. So we can say that the direction are also same here. So if the magnitude is same and the direction is same, then the vectors are said to be equal vectors. Now about types of vectors. Students, this is not given in your textbook, but I feel that even this is important to know. Types of vectors. First is parallel vectors. When can we say that the two given vectors are parallel to each other? So students, you can see here a vector P and vector Q are given. Their direction is same. You can see their direction is same here. So if the direction is same, they are parallel to each other, means they are parallel vectors. No need to check the magnitude. Here you can see that the magnitude of P is 4 centimeter and magnitude of Q is 2 centimeter. That is, one vector is larger and the other is smaller. But we don't have to consider magnitude to check whether the vectors are parallel or not. We have to only check their direction. If the direction is same, then we can say that the vectors are parallel. Now, next is anti-parallel vectors. Once again, to check whether the vectors are anti-parallel or not, you don't have to check about their magnitudes. Magnitudes can be different, but if one is having this direction and the other vector is having exactly opposite direction of that first one, then we can say that both the vectors are anti-parallel to each other. Next, about equal vectors. Now, equal vectors we have already studied. Here, whatever I explained, that was about equal vectors only. So, what are equal vectors? That we know that the direction of the two vectors should be same as well as their magnitudes must be same. Here you can see that both these vectors A and B, their direction is same, they are vertical, as well as the magnitude of A and B are 3 centimeter, means they are of equal length also. So these are equal vectors. Students, you can see here, if you compare this parallel vector and equal vectors, then we can say that equal vectors are always parallel. Equal vectors, they are always parallel. But parallel vectors may or may not be equal. You have studied about a square in lower standards. You have studied about a square and a rhombus. We know that a square is a rhombus, but rhombus may or may not be square. Square is a rhombus, but rhombus is not a square. Similarly, here equal vectors, they are always parallel, but parallel vectors may or may not be equal. Similarly, opposite vectors? Simply you have to check the direction. So first we have seen that the directions are mutually opposite to each other. But if their lengths are also equal, direction are opposite, and if lengths are equal means magnitude are same but direction is opposite, then they are called opposite vectors. And once again, opposite vectors are anti-parallel. You can see that the directions are opposite, so we can call this as an anti-parallel, but we have also seen their magnitudes, that here the magnitudes are also same. So now these vectors are specially named as opposite vectors. So opposite vectors, they are anti-parallel, but anti-parallel vectors may or may not be opposite. Now next, aparallel vectors. So students, if the vectors are neither parallel nor anti-parallel, if the vectors they are neither parallel nor anti-parallel, then that type of vectors are called aparallel vectors. You can see here this vector is having direction along this side, this vector is having direction along this side. So you can see that these two vectors, they are neither parallel nor anti-parallel, and hence they are termed as aparallel vectors. And at last, I have shown here that equal vectors, they are always parallel. See, a single implies sign is there. This is an implies sign. Single implies sign indicates that this is correct. That is, this direction is correct, but opposite may or may not be correct. Similarly, you can see for the opposite vectors. Opposite vectors are always anti-parallel, but anti-parallel vectors may or may not be opposite. So again, a single implies sign. If there is a double implies sign like this is called double implies sign. If the double implies sign is there, then both the ways are correct. So students, I hope you understand till this topic. Go through this lecture twice or thrice so that you can understand it properly.